I'm Francois Blavoet. I work as an Android engineer at Deezer. So in case you don't know Deezer, it's a music streaming application. So we have a very complex audio engine, but we are not going to talk about it today because in order to play music, we also have a very deep UI requirements. For example, we need to be able to display lyrics, make them scroll on the highlight, display an album screen with a picture of the artist, very complex track views, and so on. We even have a Tinder-like view for the onboarding process in order to let you choose your first album and artist. And last year, I have been involved in a complete rewrite of the UI. So we basically throw everything away and pushed material instead. It was a very good opportunity. So we made many changes. We dumped child fragments because it's a very bad API. We replaced list view with recycler view since there are many more possibilities in terms of animations. And we have also tried to focus on performances in UI. In particular, layouting. It's one of the common bottlenecks of the platform. On Android, we are still not able to have smooth scrolling in lists. Even now, it's a problem that is not solved. However, if we look at the material spec, one very important aspect is that motion is providing a meaning. For example, if you have a mail application and you delete a mail, you make it swipe and the rest of the list moves up. It's a very tactile experience, and since we are using our finger on the screen, it's something that is very natural. However, if the whole experience is junky, it is not at all natural. So if we take, for example, a contact application from the material spec, we can see things moving with the finger very naturally. So it's running on a Nexus 6P, one of the best phones right now. Everything follows the finger, nothing blinks in and out of existence. If I take the same application on another phone, it's not that great. And the problem is that most of our users don't have Nexus 6P. They have something like this. So it's a Galaxy Fame. It's a popular phone. It ships with 4.2 Jelly Bean. So it's something that most of us are probably supporting. To be honest, it's probably the lower bound of what we support. It's a very weak phone. It's not possible to have a perfectly smooth experience on something like this. But first, we can make things better, make them acceptable. And secondly, there is a wide spectrum of devices. And for example, we have the Moto G. It's a mid-range device. It is not great, but it's not too bad either. And with some efforts, we can have a smooth experience on these phones. And if you look at your usage stats, the Moto G is probably here somewhere in the top 10, along with other not that great devices. So what we are going to do is investigate what is going on exactly, why don't we have good performances, and what we can do about it. So first, let's define exactly what we mean by good performances. So we often are talking about the 16 millisecond target. It's simply because if you take 1 second and divide it in 60, you get 16.7. So we are trying to display 60 frames each second. Why? Quite simply because, well, it's a trick. There is no motion on the screen, it's just a succession of images, and we just need to make them fast enough in order to trick human vision. So if we look at other applications, the movies are an interesting one since it's very low, 24 frames per second, and originally it was even 16 frames per second. Well, it's a very down-to-earth reason. It's just that originally a film was very costly, so they took the lowest bound at what they could get away with. And it stays that way until now. So we can go as low as 20 frames per second at the limit. Under that, people are starting to notice that just images one after the other. Video games is another example where you can see huge differences in frame rate. And usually, games target 30, 60, or even more frames per second. And in games or mobile application, if you can miss a frame or two, it's not too bad. But if you start missing more frame, you drop for a moment under 30 or 20 frames per second, and you get junk. So junk is a discontinuity of motion, and simply you are not able to display enough frames. Let's investigate why we have this issue. So the SDK is giving us a very nice tool, SysTrace. It allows to display everything basically that happens on all the system processes. What we are going to do is take an application, make it scroll, see that it is junky, and ask SysTrace to output report. What we get is this very intimidating web page. It's actually very useful. So what we have is a representation of everything that happens. And if you look at the little F in the middle of the screen, it is just the system trying to display a frame. And it's appearing in red each time we miss one. And if we zoom in, we can see a missed frame, and we can see for this particular frame, well, we are simply performing a traversal on draw, so layouting on draw operations that are just too long, and it made us miss a frame. And by the way, if you miss a frame, you are not going to hit 17 or 18 milliseconds. The system will wait for the next frame. So it's going to be 32 or even more milliseconds before you can display anything else. So that's why very quickly long draw or layouting operation tends to accumulate and makes the whole experience very unsatisfactory. SysTrace is a very complex tool, and until quite recently, you had to spend a lot of time in order to investigate what was going on for many frames in order to identify a culprit. Fortunately, in many cases, you don't have to do that anymore. You can get some advice directly from the tool. So if we look at this report, we got some expensive bitmap uploads. Well, can't do a lot of things about it. Just use Glide, Picasso, whatever works for you. You will always have some expensive bitmaps, and most of the time it's not a big issue. Some costly draw operation, well, if that's your issue, you need to go back in time and listen to the flat as a pancake talk. Some inefficient alpha usage. Well, alpha transparency is always costly on Android. It's not well supported by all terminals, so it's often an issue. So if you can avoid using alpha and get the same rendering, do it. And finally, in our cases, expensive measure layout paths. So we have layouting issues that prevent us from getting 60 frames per second. Good. The next step is to measure layouting performances in order to know exactly where the problem is coming from. In order to do that, the platform provides a hierarchy viewer. So what it does is that it allows you to display the whole hierarchy. So Android, like most other UI framework, display layouts as boxes in other boxes, and so on. So you build a tree of views, one into the other. So on the left, you've got the road view, and at the very right, the tip of the tree. According to Chet Haas, I learned that during the previous talk, you should not use the hierarchy viewer, so it's nowhere in the documentation. It's unofficial right now. It's probably going to change. So hierarchy viewer allows you to get some information on how each node is performing relatively. It's not too accurate. So what you can do instead, it's a bit painful, but and I hope that the platform will provide it as in the next release, is just create your own layout templater, replace relative layout, linear layout on all the platform view groups by custom classes where you add some logging in order to identify where you have a layouting issue. That way, you can identify exactly what part of your view hierarchy is dragging you down, because you don't want to optimize everything. You don't have the time. You have a feature to ship like everybody else. So just focus on where you have a bottleneck. So let's dive a little bit in the code in order to understand why we have these issues with view groups. So there are two main methods in view group, onMeasure and onLayout. So onMeasure is basically here in order to make the view group measure, well, first itself, and secondly, each of its children. And so you just have to do that in order to satisfy the contracts of the platform. On layout, where you just have to say to each of the children where they are going to go exactly. If we look at relative layout, at its core, it is designed around collecting and applying constraints. So it collects rules for vertical placement, so above, below, align baseline, align top, and so on. For horizontal placement as well, so left off, right off, start, end, and so on. And what it does exactly, in order to apply all these constraints that you are going to put in your XML, is that in its onMeasure call, it's going to sort all of its children according to their relative constraint, then applies the horizontal constraint, applies vertical constraint, and then apply everything that is left, so baseline, size wrapping, right to left, and so on. In order to do so, relative layout needs two passes in onMeasure. So first to collect, then to apply. And that's why it's going to be costly. So one relative layout is not an issue, but when you start having a relative layout nested in another relative layout, nested in another relative layout, well, this double pass accumulates, and you got 2, 4, 8, it's geometrical, and very quickly it becomes too costly. So don't use relative layout if you can as the root of your view hierarchy. But by all means, use relative layouts when you need it. It is costly when you need to nest it, but if it is not creating a performance problem, it is still an awesome class that allows you to create the layouts you need. It's just that you need to know that it can very quickly become costly. What about the other classes of the platform? Linear layout is simpler, except if you need to apply a weight, since a weight is, after all, another relative constraint. Well, in that case, linear layout also needs to do 2 passes. And same thing, if you nest relative constraints, it is costly. In fact, anything relative, so percentage, weight, relative, is going to become a performance problem if you nest. What are the solutions? Well, first, avoid nesting layouts, ViewGroups, as much as possible. Use as few views as possible, so you can use computables, spannables for text views. You can pick the right view group, maybe relative layout or linear layout or grid, depending on your use case. But still, if you do that and you still don't have the performances you want, and well, you want to make your designer happy, so you want to make their awesome design, well, one potential solution is to throw away the platform classes and write your own. So framework classes like relative layouts have 3 priorities. So first, be correct, apply all your specification, be versatile, be able to handle everything above, under, below, align top, and so on. And only third, performances, as much as is possible while respecting the 2 first. So what we can do with a custom view group is forget about versatility. We want to do something specific, and that way we can still be correct and have the best performances we can for a specific arrangement of views. So we are going to take this as an example. So it's a simple album view. It's not the worst view in the world. In practice, most problematic layouts will be more complex than that. But this allows to show how layouting works without repeating too much code and show a couple of potential issues. So if I had to do this layout with the framework classes, it would look something like this. Relative layout with an image view on the left, or start. 2 other image views on the end with the earth on the start of the overflow. And then linear layout for the 2 text views I need, or maybe a spannable if it works. And I'm going to forget about it and replace relative layout with a custom view. So I'm going to keep width, height, and padding directly in the XML because I don't want to get rid of that. And I could make everything in code, but it's a good thing to keep as much specification, layouting specification as possible directly in the XML because you don't want to have an enormous custom class where it's impossible to maintain anything. And I'm going to inflate the XML normally, as I would do with the relative layout one. Then let's start writing this class. So we declare an album view, it extends directly view group. Constructor not very interesting. The only interesting thing is that we call an init method. Init, we inflate a second layout. And in there, we are just going to make a merge with the different views we need. I could have directly replaced relative layout with album view in one XML. I'm not really fond of that because it will mean that I always need to use the album view class with an exact XML, the exact same XML. So it's not very good for maintainability to couple layout on the classes that way. Instead, I just inflate it in the constructor, in the init method called by the constructor. And if I need more versatility, I can extend and call different layout depending on the cases. I get directly the different children with find view by ID, so what we will do in all cases. Then, in order to write view group, I also need to declare which layout params we want to use. So, in almost all cases, it's not the default of the platform, maybe it should be, you want to use margin layouts because you want to be able to apply margins to your children. So you just need to declare it in these two methods. So the first one is called each time you inflate a view in XML. And the second one is called when you create a view directly by the constructor. So it just supplies default layout params in that case. So let's get to the meat of view group. The first thing you need to do in a measure layout pass, well, it's measuring the views. So in the onMeasure callback, all we have to do is take each children, measure it, count how much space we are occupying, and then declare it. So let's do it for a first view. We just have to call measureChild with margin, so it's a framework method. And it's very straightforward, so the first argument is a child. The second, the width measure spec that is provided by the method. The third one, the width used so far, so since it's the first view, it's 0. Then same thing for the 8. And once we are done, we are going to count how much width we have used. Then we just repeat that for each of our children. So let's do it for the overflow, and we call the exact same method, just change the overflow, and same thing, we count how much width we are using. I'm not counting the 8, by the way, because I don't need to for this simple view. Where I know that the 8 is constant. If you have a more complex view with different layers, you will need to count it separately, but it's very repetitive and not very interesting to display. So we just call a measure child with margin on off of our children. And then, in order to satisfy the contract of onMeasure, we call setMeasureDimensions, which allows the framework to know and resolve the dimension of the view. And again, we have a framework method in order to help us. So resolve size allows us to give the width that we have used, the width measure spec provided by the method, and let the framework handle how it resolves and what it's going to be. So for example, here we are using match parent. So it is just going to be whatever width we have for this view. And for the 8, I don't even bother since I know it's a dimension directly given in the XML. I just get the size. And again, it might vary in your own view group. That's it. We have done the measure pass. Now, we need to do the layouting one. It's again a bit repetitive and not that complex, even if it can be intimidating at first. For each of our children, we are going to call a layout view, again a framework method, and it just declares to the child where it needs to go. So the first argument is a view to layout, and then you need to give it its left position, its top position, and its width on 8. So I just made a little helper method in order to apply as well the margins, since you want to keep them. And we are going to do this for each child. And for overflow, so we are directly on the right. So we need to take the white border, remove the left, since what we get in the on layout are the absolute position of the view. So in order to, in layout, give a relative relative position to the children, we need to do some simple operation. So in order to get to the right, we need to do right, minus left, minus the padding, minus the width of the view. Okay, we are directly where we want to be. I want to center the view, so same thing, I need the 8, so it's bottom minus top. I need to remove the 8 and divide by 2 in order to center. It's not that complicated. And finally, in order to lay out, I need to tell to the view how much width and height it has. So I just need to go get measure width, since that's already been done in the measure path. And the result, once we have done that for each view, is the exact same disposition we had for the relative layout implementation. But this time we are flat, we don't have any nesting, and we get pretty much the optimal measure on layout performances we can have on the platform. That way, we had a bottleneck, and we have gone as fast as possible, so hopefully it's enough. If it is not, well, let's go back to measuring our performances and optimize another view. And at the end of the day, it should be enough to get relatively smooth scrolling even on low-end devices. So what now? I have done that, a couple of months pass. I want to be able to keep these performances. Again, we have a nice tool directly in the framework, GFX info. So it's a shell command, and it allows us to get report of what happened just earlier in terms of frames. And what we get, for example, is how many junky frames we had on their percentage. So it's quite easy to create an espresso test, make it scroll in a list, and then make a GFX info run, make a report, collect the values, and if after 2 months suddenly you have a new commit and it ruins your scrolling, that way you can directly be notified. So it can be extremely useful. The only big downside of this tool is that it is only available on a terminal running Marshmallow and up. So you need to find a low middle-end Marshmallow device in order to make it work. To conclude, writing your own view group is a trade-off. You are going to spend a bit more time, not that much, but a bit more, writing code directly in Java instead of XML. On the other hand, you get performances, and you also get customization possibilities that you simply don't have on the platform. If you want to display view on a circle, well, you don't have a class for that in the platform, but you can simply write your own. So you really need to find a balance between these three things, performances, customization, versus the time you have to ship features. If you are interested by these problems, Deezer is hiring, so don't hesitate to contact us. Do you have any questions?
So when you did this in your app, what kind of percentage improvement did you see?
Sorry, didn't get you.
When you did this improvement in your app, the screen that you showed,
Yeah.
what kind of percentage gain did you get?
Well, so in percentage of junky frames, again, the big problem is that we can only use GFX info for Western devices, so not on something like a Galaxy frame. But it's important to be able to measure that, because if you just do it yourself, from one engineer to the other, you don't have the same feelings as far as performances go. But we go for something like 7–8% of a drop frame, which is way too much, to 1 or 2, which is generally smooth scrolling. Thank you.